Thanks for joining me again, everyone. Today I'm going to do a simple little solar project that'll help keep these bees cool during the hot summer so they don't have to work so hard fanning the entrance and they can get more work done. And here is the proof of concept. Little 12-volt computer fan, small 12-volt nominal solar panel. Of course, it doesn't have to be nearly this large. Now, this is a lower efficiency one. One of modern efficiency would be about a third this size to start with, but then this is 15 watts, and you could do just fine with a 5 watt. I'm going to use what I have. So of course you could do this many different ways using the same basic concept of a computer fan directly connected to a small 12-volt solar panel. So what I'm building here will just be one example, and I'll try to point out several things to pay attention to. Now I think I've gathered up pretty much everything you'll need for this project, excluding the wiring tools, which, as these are not really dangerous voltages, could be anywhere from a pocket knife and electrical tape to soldering tools and shrink tubing or weatherproof connectors, however you want to do that. And I'm going to build mine onto a spare Hive top cover that I've got here and just swap the whole cover out seasonally. But you could make your unit detachable from the cover, I suppose, and then have a small cover to go over the vented hole in the winter. So, materials-wise, I've got the spare top cover, a spare inner cover, some scraps of 1x pine lumber from the building of the hives, the shipment container that we receive the bees in. I'll be taking this screen from to protect our ventilation holes on both ends to keep bees from getting in and pests. Some nice weatherproof deck screws, and then pretty much standard carpentry tools. I've got a drill, the hot glue gun, tape measure, pencil, square, a jigsaw, and a circular saw. Now, I'm going to be using my miter saw mostly on this because I have one, but you could do it all with just a simple circular saw. You'll probably want to clamp the pieces down in this case since they're so small. And then, of course, a solar panel of your choice. About a 5 watt should do for this, and if you got a modern high-density 5 watt, it would fit right on top of this ventilation cover here. And that would be convenient if that happens to be the right amount of sun where your hives are, or you can mount your panel remotely and aim it as you see fit. So I guess I'll start from the inside of the hive, where I need to cut a ventilation hole in the inner cover here to let the hot air go up. I've got my piece of screen removed from my bee shipment box here, and I believe this is the piece of wood I'm going to use for the top of the fan housing, so I'll choose the size here for screen efficiency, keeping this piece, this width, for later. I'll cut this portion for the ventilation hole in this inner cover. And I'm making it quite a bit larger than the computer fan so as not to be restrictive. And since this is a metal screen, I'm using tin snips. Now with this piece of screen centered up in this cover, it's about 5 1/8 inches to each side from the inside edge here, so I'll pick 5 1/2 to start cutting the hole at from each direction. Now I've got sort of a rectangle there, a little bit smaller than the piece of screen. I'll just cut that out with the jigsaw, starting with a hole in 2 corners large enough for the jigsaw blade. And now, because this material is so thin, rather than use fasteners, I will use the hot glue gun. I'll just go one edge at a time to try to keep this neat. And there is a lovely ventilated inner cover. Now I have the inner cover on top of the outer cover here, but in the position that they will be when they are assembled. So I can see how things line up here with this piece of wood I've selected just because I like the look of it for the top of the air box here. We'll build 3 sides, and it'll be standing up about here on top of the box, and change the air's direction from blowing straight up to out the front. Now I want this to have a bit of an overhang to help keep the rain out of the outlet here. About 3/4 of an inch there. Now if there's framing holding this up, then there's another 3/4 of an inch before we can put the fan there. So the fan would be about there, which is awfully close to the center of the cutout in the inner cover, and there is that 1/4 inch space between them. This will be up a bit to allow air in, so it looks like that'll work just fine. We'll get that out of the way and position this top piece with the slight overhang, as I said. I'll get it centered this way, and I'll draw a line around these 3 sides. Now subtract the width of the fan from the width of this and divide it in half. That's 11 3/8 minus 3 1/8 for 8 1/4 divided by 2 being 4 1/8. Make it 4 1/8 from this side and 4 1/8 from that side. Now there, I've just gone over everything with marker so you can see it on camera, and I want to mount the fan on top of this top, not in it, so I can just freehand some 45-degree angles here to leave in place to screw the fan to. Now I can drill a starting hole and cut that out with a jigsaw. And you can see I stayed on the inside of the lines here to make sure not to go overboard. And I happen to have this piece that's about 2 5/8 wide. That looks like a reasonable height here. Enough air space there. And there are 2 sides and a back. And then the top with slight overhang. That's pretty much the deal. Now you would paint all of these at this point, and you could even put aluminum or something on top of this one like you would with a lid, but I will continue showing the construction. I'm going to hold all of these parts together with some 1 5/8 deck screws. So we'll just drill a couple pilot holes in each end here, and then screw them together. And with that all one unit, I will drill pilot holes through the lid, and then use this piece of wood, knowing that it is cut squarely, to square up this frame. Start at one end, screwing it together, and make sure that I hold these sides flush to the sides of the top as I'm screwing those together. There are the holes. Got 3 on each side and 2 in the back. Got a bit ahead of myself there, but now it's easier for you to see. Here is the front face of it, and in order to install the screen, I want to cut a groove in the bottom of this top piece, right in line with where the sides are. So just one saw blade set halfway down, about 3/8 of an inch deep. About like so. So that the screen will go into it there. Give this screen edge a bit of a hem. Just place it here and fold it over so that I have a nice straight and rigid edge. It's a little ragged. And that goes right in there. And then to hold the bottom edge, I'm just going to fold this again. Now this is thin enough, I can just screw it down here and that'll hold itself. Now I can use the 1 5/8 screws again to attach the box to the lid from below. Having this perimeter line here, I can now just drill pilot holes about 3/8 of an inch inside the line to be in the center of the lumber, like so. I'll need one more thing here, and that's a hole for the wires to pass through. I'll put that on the back piece so it doesn't tend to let water in, even if it isn't sealed perfectly. So just line this up where it goes. Position the fan on its outline. Make a mark right there, and then the height of the wire is just under that. right there. And then after it's all assembled and painted, I can seal up this hole with some caulk on the outside. Now I should be able to assemble everything. Twist those together to get them started. There's that. I can screw the fan down, drill some pilot holes because there's very little wood left there. And actually I'll just use some drywall screws since this will be protected from the weather, so that I can do it with a manual screwdriver for a little better control here. And 2 of those will be plenty. Now I'll just fold this down, keeping the screen tightly in place there. Pull the slack out of the wires, and I can screw it down from the inside. And this is where you could use the help of a clamp. I prefer to do it the hard way. And there's that. There's the front of it. Let's test the airflow. As the sun is on its way down right now, and I've already tested that part, I'll just use a power supply. And the air is definitely coming out the front there with a 12-volt power supply on it. Like so. And if you have your solar panel a little bit oversized, a 12-volt nominal panel is going to run this at an even higher voltage and get quite a bit of flow when there's direct sun. So I will get this painted and I'll install it tomorrow. Well folks, after seeing it all assembled, I decided to go ahead and order the nice, cute, appropriate sized solar panel for this. This is a 5 watt, it's a pretty common size, and I think it's a good one for this because it gives a little more output than we need at full sun. The computer fan generally has an amperage listed on it, which is for one of these little 3-inch common fans is around 0.2, a little less generally. So you multiply the amperage by the voltage and you get watts, around 2.5 watts. That's so that this fan can still run a little bit when it's a bit cloudy outside, because especially in a place like this, it can get into the upper 90s in the summer. So even though we have this installed under a nice shade tree where it gets a lot of shade at midday in the summer, we'll still want that fan to be running. But all that'll depend on your situation. Because of our situation, I am going to go ahead and install a longer bit of wire on this and just have it sitting here normally, but have the ability to place this somewhere else that gets more sun if it's too shady to run at the speed that we'd like when it's very hot. So I have options here, and this isn't likely to blow away. And this panel happens to have these convenient little screw terminals marked positive and negative, and this is just positive to fan positive and negative to fan negative. Very simple. We'll just strip about 1/2 inch of wire there, twist them tightly together, and bend it into a loop. And you want to wrap it in the tightening direction so that it pulls the wire onto or more tightly around the screw instead of working against you. And for a connection to the fan, I'm just going to twist the wires together, fold them over, and tape them. Right, generally want to make a stronger connection than that. In this case, if something's tugging on this solar panel trying to pull it apart, you'd kind of rather it come apart than keep pulling on the Beehive. And then for transport, and until I decide if I'm going to place this panel remotely, I can just coil up this extra wire and put a twisty tie on it. Alright, let's go try it out in the sun. And there's a pretty good example of how a 5 watt panel is properly sized for this application. It is pretty cloudy out here. You can see the sun is just barely coming through, and the fan is running very gently, almost silently. Remove the regular cover, which will now be the winter cover, inner cover, fit with our new vented cover, and the solar powered lid. So there you have it. We'll see how the bees like that. Don't forget to express your feelings with those like and dislike buttons and your thoughts in the comment section below. And don't forget to subscribe too. Thanks for watching. And there they are, being merrily along with their exhaust fan running swiftly. And it's gotten even cloudier since that last scene, but the fan is still just barely running, which is nice. So I think I'll leave that panel right there for now.